All right, so let's try this again here. So today we are looking at one specific thing, the maximum or minimum value of your quadratic function. So this should come pretty intuitively after we've been talking about these graphs, because if your quadratic function opens up, so if your parabola is going to open up, that means that the vertex is going to be the lowest point on the parabola. So that means that your parabola would have a minimum value. If your parabola opens down, the vertex is going to be the highest point on your graph, which means you're going to have a maximum value for that quadratic. So that's all this is saying. We're starting with that quadratic in the expanded general form. So we've got f of x equals ax squared plus bx plus c. So if a is greater than 0, that means your parabola opens up. So that means that your function has a minimum value. So remember, f of negative b over 2a, what is that? We talked about that yesterday. It's part of the vertex. Which part?
Is that how you find like your x value?
Not quite. The negative b over 2a is how we find your x.
Oh, that's how
So what's f of that? Right. So this is just the y from your vertex.
Oh.
And it would help if I actually wrote y. Let's try that. Okay. So yeah, f of negative b over 2a, that's just your y coordinate from your vertex. And that minimum value happens at x equals negative b over 2a. Well, what's just negative b over 2a? Yeah, that's the x coordinate from your vertex.
So much information.
It's just kind of phrasing things a little bit differently. But it's the same stuff we looked at yesterday, really. So yeah, if your parabola opens up, then you're going to have a minimum of whatever your y coordinate of your vertex is at x equals whatever your x coordinate was. So really, whenever you're looking for this minimum or maximum value, that's just a different way of saying find the vertex. So we're not actually going to write it as an ordered pair, but that's essentially all we're going to be doing is finding the vertex. So if your a is less than 0, that means you're going to open down. So it has a maximum value of whatever your y coordinate from your vertex is again, at, and then whatever the x coordinate is. So your y value is the actual maximum or minimum, and the x is the location of that maximum or minimum. So today we're just going to kind of work with finding these values, and then next week, early in the week, we're going to look at some word problems where we can actually see like a lot of things actually travel in quadratic functions, so follow like a parabolic curve during movement. So we'll look at how you can find like the maximum height of objects and that sort of thing. Okay, so here we have a quadratic function. First thing we're going to do is figure out, does it have a maximum or a minimum? So we're not actually going to graph these to where we look at the picture and go, oh, okay. Because we have enough ways of telling things without actually having to look at the graph when it comes to a parabola. So we're going to figure out, does it have a max or min? Then we're going to find that maximum or minimum value and say where it happens. And we're also going to give the domain and range without graphing. So our first function, we've got f of x equals 3x squared minus 12x minus 1. So, would this parabola open up or open down? It's going to open up. So is it going to have a maximum or a minimum value? Minimum. Okay, so then if we want to actually find that maximum or minimum and where it happens, well, our minimum value is going to be the y coordinate of the vertex, and where it happens is going to be the x coordinate. So we just have to find the vertex like we did yesterday before we graphed. So how do we find the x coordinate of our vertex?
Plug in 0 for the y.
No, that's how we find the x-intercepts.
Use
Like
negative
the
b
negative
over
b.
The negative b over 2a. That's how we found the x-coordinate. So let's see. Negative, what's our b in this case?
negative 12,
Negative 12 over 2 times a. What's a?
3.
All right, so we would get negative 12, so 12 over 6. So we know the location. We're going to have our minimum when x is equal to 2. We just need to figure out what that value is. So if we put 2 back into the original, let's see, that would give us 4, 12, 4, negative 12. I think that's going to be a negative 13.
Wait, I have a question.
Yes.
Okay, so whenever it says find the minimum or maximum value and determine where it occurs, you're just finding the vertex.
Finding a vertex, and we're just going to write it slightly differently. We're not going to write it as an ordered pair. But yeah, all of it is finding the vertex. Yes.
How'd you know if it's maximum?
Because if it opens up, think about drawing your parabola. Is that going to have a highest or a lowest point? It's open up. So that's why it's a minimum. But if it opens down, it'll have a highest point, so it'll be a maximum.
Thank you.
Okay, that is indeed negative 13. So what we can say is we've got a minimum of negative 13 at x equals 2. So like I said, we're just finding vertex, we're just writing it a little bit differently today. All right, and then, pardon?
Question.
Oh. And then the last step we want our domain and our range. What's the domain always?
All real.
All reals. Okay, so then for our range, since we have a minimum value, what is the lowest y value we're going to hit?
Negative
13.
Right, and we're going to hit everything above that, right? So it's going to be from negative 13 to infinity. So any other questions with our first one before we look at our second equation here? All right, so then same deal, we've got f of x equals 5x squared minus 5x. Is this going to have a maximum or a minimum value?
Minimum.
Yeah, it's going to have a minimum value again. Oops. All right, so then we need to find where that happens. What is b this time?
Negative 5.
What's a?
5.
5. So let's see, we're going to have 5 over 10. So that's going to be at 1/2 this time. And I'm not going to attempt to do that in my head. Why? It's supposed to be gorgeous today.
I mean, like, this is actually like one time where it'd be alright if it rained, because it does feel good outside.
Okay.
I mean, look at my hair.
So I believe our y coordinate's going to be a negative 1 1/4 then. All right, so what we can say based on this is that we've got a minimum of negative 1 1/4 at x equals 1/2.
If you don't put the x equals, would it be wrong?
Yes, because it asks where it occurs. So that's why we need that. If you were just asked for the minimum value, you absolutely don't need the x. But when it says and where does it occur or at which value does it occur, you need that location x.
So could you like switch the numbers then, since you have which one's x like labeled?
What do you mean when you say switch the numbers?
Could you be like min at x equals 1/2 of?
Oh yeah, absolutely. That would be fine. So yeah, if you want to say it in the opposite order, that's fine. Sorry, I was concerned that you were wanting to say that we had a minimum of 1/2. But yeah, if you want to switch the actual order in which you write it, that's totally fine.
Well, if you just kept the x equals, could you say that then, like the min of x equals 1/2?
No,
Because then that'd be switching.
right, because that would be like saying that the minimum value is the 1/2 when that's the location of our minimum value. Yes.
Can you write it as negative 5 over 4?
Sure. Okay, so then for part C, what's our domain?
All real.
Okay, and what would our range be for this one?
-1 over 4 to infinity.
Yep. So anything else with either of these two? All right, so how are we feeling so far about these maximum and minimum values and 1s, 2s, 3s, 4s, 5s? All right. Okay, so the next thing we're gonna do, no, that's not my project. Is your project okay?
Yeah,
Or I can
okay.
be laughing.
Yeah.
Sorry, your response is just fantastic, and I'm
Well, I
really grateful
super
that
flew
that
last
is recorded.
night.
So if somebody watches it at the home, they're here. No, not my project.
I wonder if my dad watches now.
Well,
So
like,
he can make fun of you.
this is, look at this, I super glued it last night, but it didn't stay. It was
Why
just-
don't you put that on maybe the table in front of you so that
It's
that
okay.
doesn't happen again?
So is that for chemistry, you need to be
Okay.
careful.
All right, so not that we've wasted a minute. This is fun. Give the domain and the range of our function based on the description.
Well, hopefully you weren't going down to the last second. on
Well,
this
we'll
one.
see. If so, oh well, worth it. All right, our vertex is going to be -1, -2, and our parabola is going to open up. So what would our domain be?
All reals.
That one's a gimme. Just remember to write it down. Okay, and then what about our range for this one?
-2 to infinity.
-2 to infinity.
I feel like this is a really easy thing to overthink.
It absolutely is.
That's all we have to do.
Yeah, we just asked for domain and range. So, woo. All right, so the next one, we've got a maximum value that equals a -6, and that's going to happen at x equals 10. What's our domain?
All reals.
Gotta love that one. Okay, and then our range.
-6 to infinity.
No, it is.
Infinite.
Negative
It's,
infinity
it is,
to
well,
negative
no, it's like.
infinity.
No, it's not
negative
using the
infinity
10,
to
because remember, the 10 is the location.
Oh, my bad.
So that's
So
not it.
Oh,
Negative
-6 to
Negative
negative
infinity.
It's go
Negative
down.
infinity to negative
So
Negative infinity to -6.
Oh,
So right,
sorry.
because if it's got a maximum value, that means that it's open down. So yeah, it's gonna go from negative infinity to -6.
I
So
thought
you
it
don't
said
do anything with
minimum
the
for some reason.
Nope. Because that does not impact, because the domain, we know it's always all reals. And domain is what's gonna deal with the location, because that's talking about axes. Alright, anything else with these two?
How come you don't use the 10 at all?
How do we don't use what?
How come we don't use like the 10 like?
Because that's talking about an x value is part of your domain. And what's the domain? Always.
All reals.
There we go. So I could have said at x equals 10 million, and it's not gonna impact anything.
Oh.
Yes, the joy of the domain. It's a fabulous thing about parabolas, it's always the same. Alright, anything else with these two? Alright, then I think we had 2 more if I'm remembering correctly. Okay. So we want to write our equation in standard form. So this is going to be like what we talked about a little bit yesterday, but I said you didn't have to write them in standard form. We're going to put them in standard form today. So it's going to follow the same shape of f of x equals 2x squared, but it's going to have the vertex of 5, 3. So when it says the same shape, what are they actually telling us there? Yeah, it's telling us it's going to go up. We know it's going to be a parabola. What else? And so the 2 told us that it was going to go up. What else does the 2 tell us?
That is like
Right, it's going to be something that's going to be stretched a little bit, because if you think back to those transformations, it's going to be a little bit taller graph. So is that 2 going to be part of our equation?
No. Yes.
You said that so definitively too. But yeah, it is. So that 2 is telling us essentially our A.
so
So
like
where does A go in that general form?
first, so it'd be like 2 parentheses x minus 5 squared plus 3.
Yep.